everyone. Welcome to a tutorial of how to use this meta-heuristics toolbox for global optimization, which was developed by me, Bentakiti Sanan. So firstly, let's get to know about this toolbox. Basically, this toolbox is an interface that contains meta-heuristics, mainly for optimizing single and multi-objective optimization problems, and also support many objective optimization. Even the solvers are still cannot solve it effectively. More than that, it also supports a simulation-based optimization, where the simulator is Aspen Plus. And this toolbox consists of 5 main parts. First is the problem specification panel, variable setting, stop criterion, and parameter setting panels in data tab and a result tab. Next is about how it works. It works by receiving input data and send it to a specified optimizer here in a main file before displaying the result in this result tab. Now, I will show you the examples, which consist of single objective, multi-objective, many objective, and simulation-based problems. Let's start with how to solve this joyful 1.2 function. Here, start by here. Input the number of objectives as 1, since it is a single objective optimization. And next, there are 4 choices of single objective solvers, which are LHS, Harmony Search, Gray Wolf Optimizer, and Modified Gray Wolf Optimizer. And let's say we go into choose here, and then we can notice that this panel is changed from LHS parameter setting to modified Gray Wolf parameter setting. Then input a function file, which can be input by 3 ways. First is by typing its name. Second is by choosing its file, which is F1. And if you want to create a new one, you can click this new button. Then this function with the guideline of how to write the function file will be popped up like this. And then from the problem, global optimum is 0, so input here 0. And here you can change the name of y-axis or the name of the objective value in the convergence curve, and input here number of function evaluation as 1. And next, for the number of runs, in case you would like to run more than once in a time, you can increase this value. Let's say we will run it 2 rounds. And next, for the lower bound, upper bound, you can input it just once, like this. For example, input it 10 dimension from -1 to 1. And click solve. Here you can see that lower bound, upper bound will have 10 value. Or you can even input it like this. Here, you can get the same result. Or in case that you would like to repeat just the last value, it's gonna be like this. But a warning is that you have to input numbers with spaces between them, like this, and this is allowable format, or it can turn out like this. I will show you. Here, click solve, and here, see, instead of input 1 and 3, it turns out into 13. Now let's go back to the problem. Okay, lower bound is minus 100, upper bound is 100 with the dimension of 15. And next, in a stop criterion, maximum number of function evaluation is an approximate value, since all of the solvers controlled by the maximum iteration value. So this value will be converged to the maximum iteration. That's why the final value of number of function evaluation might not equal to the value that you input here. So it comes to the second warning, which these are the equation for the calculation of minimum of the maximum number of function evaluation to get one iteration. And then before the optimization, if you want to save a result or do the real-time plotting, you can turn this button to on. And let's say we want to do 80 iterations. Click solve. Here is a real-time plotting. And finally, after the optimizing, in a result tab, it will show the convergence curve of the base round if number of runs is more than 1. And here is an error of this output from the optimum you input here. Here is the error. And next, for multi-objective optimization, here is 3 objectives, so we put it 3. And also for multi-objective optimization, there are 4 solvers provide here, which are an SGA2, multi-objective company search, multi-objective LHS, and multi-objective modified gray wolf. Let's choose multi-objective LHS and choose a function file, which is F7. And here we can input through Pareto front, maybe by typing, or choose here. And then if you would like to know a compromise solution based on a Topsys analysis, just tick this box and input subjective weights. Next, for the search range is 0 to 1. Or maybe if you have initial population, you can click here. And let's do just 3 iterations with the real-time plotting. Click solve. Here, a real-time plotting. And in the result, the Pareto curve, you can rotate it to see the correlation or use this replot button Let's say we want to see the correlation of F2 and F3. Just turn it and replot. Or you can change its name here. And next, for many objective optimization, it is 5 objective. And then if you don't have a true operator front, you can click browse and click cancel to reset its setting, as well as for the initial population or even the Aspen Plus file. And then dimension of 5. Okay, click solve. It will show a coordinate plot here and also here, which can also use a replot button like this. The last example is a simulation-based optimization of ethanol distillation column, which you can visit here for more details. Now, input number of objective as 2. Since we want to minimize CAPEX and OPEX. And then choose Aspen Plus file by click this all file and this ethanol column. And also choose function file, which is fun objective here. And input lower bound, upper bound, which are 0.0. Now 63 and 1 with dimension of 3. And here, since h1 is an integer, so we input this position of the integer as 1. And for this part, it is another warning that if so, and that's it. I hope this toolbox will help you to do your optimization work. Thank you. There is the axis of maximization. The maximization must be placed before the minimization to converge the negative of the maximization objective value to positive for the final plot or this plot. But if you don't mind about the value of the plot, you can skip this part. And here is a result with subsys analysis where the subjective weights are 0.5 and 0.5. And lastly, if you want to add more solvers in this toolbox, you can do it by add your solvers by here. Click the plus button and type its name. Then use this panel to create the parameter setting panel and also the edit field like this. And then in a code wheel, click this solve button, value change to make it appear or disappear by using dot visible on or off. And next in solve push button, you can add the parameters here by use the case and type its name and put the parameters as this format, as well as in a main file. Just type its name and type as this format. And that's it. So now you can use this toolbox with your uh, developed software. So lastly, I hope this toolbox will help you to do your optimization work. And thank you.